had to extend this part out here a little ways. And that, so now I think it's in there focused.
This doesn't have a solar reflector on it, does it?
Yes.
Oh, hello, here it does.
Yeah, it does.
Good, okay.
Anyway, there it is.
Good. Fantastic.
My name is Robin, and you're at the Community Observatory of El Dorado County, and this facility is right off of Missouri Flat Road, just down from the overpass and the shopping centers, right here in the county. And it was founded around 2005 by the Cameron Park Rotary. They thought of some ideas of what to do for the service of the community, and so they thought of putting together this entire observatory. Pretty much through Art Court was the one that really had the brainstorming ideas. So they put together a lot of money, about $237,000, and built this observatory with a retractable roof, and the parking, the pave, and so forth. And we had two C-14s in here at that time by Celestron. Since then, just about a year and a half ago, they got a donation from the Aerogeo General Corporation of $22,000 to put in a 17-inch plane wave. So we have a 17-inch plane wave telescope inside the observatory and a C-14 that's hooked up to a video camera and a monitor that has time exposure so that you can see deep sky objects like the planetary nebulas, galaxies, etc. on the monitor. It's pretty nice, it's in color. And we also have another room set aside for educational purposes. And then about a year and a half ago, the Rotary came back and built a sky theater off to our right over here, your left. And that seats about 50 people. It's like an outdoor type of a planetarium where the presentations can be made at night, all about the Milky Way galaxy, deep sky objects, the stars, etc. Today, this is a Saturday, the first Saturday of every month. We have Solar Saturday, where we set it up from 10 a.m. to noon, where we have solar scopes set up to look at the sun. The public is more than welcome to come out at that time. There's free parking right down here at the college. They offer that. And just walk up the pathway, and here we are, and we'll be glad to entertain you, socialize you, and give you all kinds of education on the sun and at nighttime on all the nighttime astronomy.
Dobsonian telescope. It's made by Light Bridge. It's made by me. It's called the Light Bridge. But what I've done with this one is I've mechanized it. I've put servos on it. You can see the belt-driven servo here. It's computerized. And I've also got a astronomical software that's connected to that belt-driven system. And so basically when I get it all aligned, it'll follow whatever object I put it on. And when I want to go to a new object, I tell it what I want to look at, and it goes to that object. So it's called a go-to, which is more fun because it stays on the object when I'm showing people, and I don't have to keep shoving the telescope because the Earth's rotation keeps the object going out of the field of view. So it's fun. I'm going to wait until it gets a little darker, the sun gets down a little lower, and then I'm going to align it. And then I'll put it on the moon because the moon's up already, so we'll take that. And then as soon as the sun goes down, we'll take a look for Jupiter over here, because it'll be behind the wall. The telescopes inside won't be able to see it.
This is the Celestron C-14 that was donated by the Rotary Club. And you can see all of this cabling and wiring. It's hooked up to a video camera, so you really can't see through the C-14, but the cabling, etc., goes to a monitor right behind you that's color, and it has anywhere from an 8-second to 30-second time delay to allow more light exposure into the camera via the telescope so that we can look at deep sky objects, which we normally can't see that clear with a regular telescope without a camera. Attached to it is a 4-inch refractor that is used to spot and look for the objects to bring them in closer. And right now it's hooked up to be looking at the sun. We have solar filters on both sides, so that's what we're doing here today.
My name is Dale. We're up here at the observatory. We're looking now at the 17-inch Dal Kirkham plane wave generated or donated by GenCorp, Aerojet. It's a 17-inch reflector telescope. It has a fairly long focal length. It's a compact unit because the mirror, the primary mirror, The light comes in through the primary mirror. That's an ellipsoidal curve. It bounces back up to a secondary mirror, which is a spherical curve, brings it back down to the eyepiece. So even with a longer focal length, we have a compact tube. And this is a stress tube, so it's a lightweight. It's the fiber tube, very lightweight. It's corrected, so the astigmatism and all of that is gone. It gives clear images of stars clear out to the edges of the mirror. So this is an excellent telescope. This was replaced here just a year and a half ago. We replaced a 14-inch identical to the other telescope that we have the Cam camera on. This is a real professional level telescope. So we're really happy to get this. We also have a finder scope, a stellar view finder scope. It's very nice. And we also use what they call a TELRAD. That's my favorite method of locating deep sky objects or things that are visible more than the deep sky stuff. If you're looking for stars like Alberio, the double star, the one that's blue and the other one's gold, that's why they call it the Cub Scout star. To find those, you can just look through this TELRAD, center it through there's 3 red rings that you can use for guiding. Very nice, cheap. A lot of people have those on their personal telescope. But with this German equatorial mount, we have the go-to function, and this little computer in the paddle, they call it, has about 40,000 celestial objects that we can go to. So we can just use a menu, enter it, and the motors and the drive automatically go to that object. Very nice. This whole telescope is mounted on this stand that's down about 8 foot into the bedrock. And very steady and strong. And you can notice this material on the edges. It's soft to the touch. It's almost like a car tire. And that's so that the telescope is actually isolated from the building. You can have an elephant dance, I'll give it a shot. And you're not going to affect the telescope.
Anyway, my name's Bill. I'm a solar docent with the Community Observatory here, and we're actually at Folsom Lake College, but it's a Cameron Park Community Observatory sponsored by the Rotary Club. Anyway, they have several nice big scopes in here for night use, and then outside here, these are my own scopes. We have 2 types of telescopes. One of them well, both of these are just for looking at the sun right now. This one here is what's called a hydrogen alpha scope, and it only allows one narrow bandwidth of the sun through so that you can see solar prominences and solar flare. And the other scope filters out all the white light and shows just the sunspots, which are, the sunspots are black spots on the face of the sun, which are cooler spots than the rest, and so they look black. The solar prominences here in this scope are about 50-60,000 miles coming off the surface. And the one little dark spot on the sun you can see is about the size of the Earth. These prominences are hydrogen gas, and sometimes you can, they're what's called filaments, and they're on the face of the sun, and that's where they're coming towards us, and as they lift off from the sun, they cool down and show as a darker streak. And if you look through this one, you should be able to see sunspots. Those black spots on the face. This 13.5-pound meteorite crashed to Earth about 5 5,000 years ago in northern Argentina. Although they think it's probably about 5 billion years old. And it's an iron nickel meteorite, which is 95% iron and about 5% nickel and a few other elements. This is probably what the Earth's core is made of. You know, the Earth has an iron core.
Yeah.
This is probably the core coming from a piece of a planet that broke up probably in the asteroid belt. And there's little pieces of it flying all over, and this crashed to Earth. There's many pieces of this that are bigger than cars that are in museums and stuff. So there's a lot of this that was strewn over a big, long path in northern Argentina. Since there's so many pieces of it around, it makes it relatively inexpensive. Whereas the one that crashed near Coloma recently, there were just a few pieces of that, and not very many have been found, and a lot of notoriety. So those are very, very valuable.
So we're in the Sky Theater up at the Cameron Park Observatory. This was built a couple of years ago by the Rotary Club. It's designed so that you can recline back about a 45-degree angle and just sit and observe the night sky. We can explain a little about the horizon line, the meridian, what the zenith is, the ecliptic. Yeah, before we had the green lasers, we would have to tell people that, well, we'd point and say, it's right there, that's Arcturus. And everybody would be trying to get behind you to see where you're pointing. And of course, if you're all sitting around in a circle here, it didn't work out very well. But with our green lasers now, we can just point to our object, and everybody in the Sky Theater just follows your green laser right up to the object that you're looking for. Works out really nice. So every Friday, Saturday, and Sunday when we're open, we do give a Sky Theater tour, and we have a list of the prominent things that we want to talk about and show. Then we ask the people what they would like to see. A lot of them have favorite objects. So we can go out here, point them out with the laser, and then take them back inside the observatory and show them with the telescopes. That makes it out very nicely.
Since the observatory's been open since 2005, almost 39,000 visitors have visited in that 6 or 7 year period of time. And they had not plateaued yet. There still seems to be more people visiting us each and every year. So please come on out whenever you get a chance. That's Friday, Saturdays, and Sunday nights. There's also special viewings during the week, and you can contact the observatory online.